January 31st, 1945, a seemingly ordinary inspection would change everything. Major Frank T. McCoy found an intact Japanese G4M Betty bomber at Clark Air Base, abandoned, undamaged, ready to reveal its secrets. When he climbed inside the wings to examine the fuel system, he expected to find the standard protection every military aircraft carried: self-sealing tanks, armor plating, fire suppression. He found none of it. The fuel tanks were completely naked, just thin aluminum barely 2 millimeters thick, separating enemy bullets from thousands of liters of high-octane fuel. This wasn't damage from combat. This wasn't a field modification. This was how Japan designed their most important bomber. And in that single design choice lay the explanation for everything. Why the Betty dominated early Pacific combat, why it later became known as the Flying Zippo, and why thousands of Japanese airmen died in aircraft that exploded at the slightest hit. McCoy ran his hand along the interior surface of the fuel cell. The metal flexed under minimal pressure. He could puncture it with a screwdriver. A single .50 caliber round would tear through both sides without slowing down. The wing held over 4,000 liters of aviation fuel, enough to fly halfway across the Pacific, protected by metal thinner than a soda can. He photographed everything. The fuel cell construction, the complete absence of rubber self-sealing compound that automatically closed bullet holes. The lack of carbon dioxide fire suppression systems standard in every American bomber. The missing armor plating that protected Allied fuel tanks from ground fire. Before we continue, click that subscribe button, like this video, and let me know in the comments where you're watching from. It brings me great joy knowing that these war stories and lessons get to people all over the world. Your support helps us bring more thrilling war stories, and trust me, you won't want to miss them. Now let's get back to the story. McCoy had examined dozens of crashed Japanese aircraft. He'd seen the lightweight construction of Zero fighters, their lack of armor traded for maneuverability. But those were fighters, small, agile aircraft where minimal weight made tactical sense. This was a bomber, a strategic aircraft designed to carry tons of bombs across ocean distances. An aircraft that required crew survivability for long-range missions. Yet Japanese engineers had deliberately stripped away every protective feature Western air forces considered essential. The Technical Air Intelligence Unit would spend weeks analyzing this single aircraft. They'd measure fuel capacity against weight savings. They'd calculate the range advantage gained by eliminating protection systems. They'd compare Betty specifications against American B-25 and B-26 medium bombers. But standing in the tropical heat of Clark Field, McCoy already understood the fundamental trade-off. Japan had built a bomber that could fly farther than any Allied aircraft. They'd achieved range that redefined Pacific warfare. They'd created a weapon that could strike targets previously considered unreachable. The price was written in bare aluminum. Every Betty crew flew knowing a single tracer round could ignite their fuel. Every mission was a calculated risk that survival depended entirely on avoiding combat. Every sortie accepted that interception meant almost certain death. Why would anyone build a bomber like this? The answer would explain not just an aircraft, but an entire philosophy of war, one that valued capability over survivability, performance over protection, strategic reach over the lives of the men who flew the missions. And that philosophy was about to collide with American fighter strength across every battlefield in the Pacific. The answer to McCoy's question began 4 years earlier, when those gun-protected fuel tanks weren't a liability. They were Japan's greatest strategic advantage. December 8, 1941, Clark Air Base. 82 G4M Betty bombers lifted off from Formosa at dawn, their massive fuel cells filled to capacity. The target lay 460 miles away, a distance no American medium bomber could match. The unprotected tanks that would later doom the Betty now enabled what seemed impossible, striking deep into enemy territory from bases safely beyond retaliation range. At 12:35 in the afternoon, the formation arrived over Clark Field at 20,000 feet. 27 bombers from the lead wave dropped 636 bombs across the runways and facilities. Minutes later, Zero fighters swept in at treetop level, their guns tearing apart everything that survived the bombing run. 45 minutes, that's all it took to eliminate American air power in the Philippines. 12 B-17 flying fortresses destroyed. Nearly every P-40 Warhawk reduced to burning wreckage. The few American fighters that scrambled arrived too late, finding only empty sky as the Betty formation withdrew north, untouched, unopposed, already beyond pursuit range. Lieutenant James Harrington watched from a bomb shelter as the attack unfolded. "Perfect formation, high altitude, totally beyond our reach," he wrote in his combat report. "We couldn't get a single plane airborne." The Betty had demonstrated something unprecedented, the ability to project devastating force across distances that redefined Pacific warfare. 2 days later, the Betty proved it could sink battleships. December 10, 1941, 26 G4M bombers joined older G3M models in attacking Force Z, a British naval task force built around HMS Prince of Wales and HMS Repulse. The bombers approached in coordinated waves at 12:20 in the afternoon, each Betty carrying an 840-kilogram Type 91 aerial torpedo. The attack was surgical. Prince of Wales, a 43,000-ton battleship representing British naval supremacy, took 6 torpedo hits. Repulse absorbed 4 while attempting evasive maneuvers. Both capital ships capsized within 2 hours. 841 sailors died. For the first time in history, capital ships actively defending themselves had been sunk solely by air power in open water. Naval theorists had debated the possibility for decades. The Betty had settled the argument in 90 minutes. Across the Pacific, the pattern repeated. Betty bombers hit Darwin, Australia from bases 3,500 miles away. They attacked Port Moresby from airfields across New Guinea's mountain ranges. They struck Guadalcanal from Rabaul. 600 miles of open ocean crossed as if distance meant nothing. Allied commanders faced an impossible equation. American fighters lacked the range to intercept bombers departing from distant Japanese bases. Allied airfields came under attack from bases that were themselves beyond Allied striking range. The Betty could hit any target across the Pacific while remaining effectively immune to counterattack. The aircraft became the symbol of Japanese air power's reach. Through the first 6 months of 1942, Bettys participated in virtually every offensive operation across Southeast Asia and the Pacific. They supported naval operations, conducted reconnaissance beyond Allied capability, and maintained pressure on positions Allied forces couldn't adequately defend. As long as Allied fighter opposition remained limited, as long as Betty formations could approach at high altitude and depart before interception, the unprotected fuel tanks were irrelevant. Range was everything. Survival was assumed. That assumption was about to become fatal. August 8, 1942, the advantage evaporated in fire. 23 G4M bombers from the 4th Air Group departed Rabaul at dawn, bound for American positions at Guadalcanal, the same 600-mile route they'd flown unopposed for months, the same high-altitude approach that had protected them throughout the campaign's opening phase. But Guadalcanal had changed everything. American fighter strength had increased. Wildcats now operated from Henderson Field, the captured airstrip Japanese forces had built, but never used. For the first time, Betty formations would face sustained interception over their targets. The fighters hit them over Savo Island. What happened next shocked both sides. Betty bombers didn't absorb damage and limp home like American B-17s or B-25s. They didn't catch fire gradually, giving crews time to bail out. They exploded. Instantly. Catastrophically. One moment, a bomber flew in formation. The next, a fireball expanding across the sky with debris raining into the ocean below. 18 of 23 Bettys were destroyed. Approximately 120 aviators killed. The single worst G4M loss of the entire campaign. American pilots reported the same observation across every engagement. Minimal hits produced maximum destruction. A short burst from wing-mounted 50-caliber machine guns didn't damage a Betty. It detonated it. Tracer rounds ignited fuel that had nowhere to go, no self-sealing compound to contain the fire, no suppression systems to starve the flames. The thin aluminum skin that enabled exceptional range now became a death sentence. The nicknames emerged immediately. Flying Zippo. One-shot lighter. Flying cigar. American pilots stopped counting victories and started counting fireballs. Japanese crews began referring to their own aircraft as hamaki, cigar, acknowledging what everyone knew but couldn't change. The mathematics became brutal. Betty formations suffered 30-40% losses on missions where American fighters achieved interception. Some raids lost over 70% of participating aircraft. Experienced crews, trained navigators, skilled bombardiers, veteran pilots were dying faster than Japan could replace them. At Rabaul, Betty squadrons that had dominated the campaign's opening months were reduced to skeleton strength within weeks. The 4th Air Group, which had struck Force Zid and annihilated Clark Field, lost 78 aircraft in the Guadalcanal campaign alone. The Kanoya Air Group was effectively destroyed as a fighting unit by October 1942. Ground crews watched bombers depart knowing the odds. Flight engineers calculated fuel loads understanding that every liter increased range and vulnerability simultaneously. Pilots accepted missions aware that encountering American fighters meant almost certain death, not from superior tactics or overwhelming numbers, but from a design decision made 5 years earlier in a Mitsubishi engineering office. The tactical equation had reversed completely. The same unprotected fuel tanks that enabled strategic reach across the Pacific now made every mission a calculated sacrifice. Range still existed. Bettys could still fly 600 miles to Guadalcanal. But survivability had collapsed to near zero. Japan faced an impossible choice: continue flying missions with unsustainable losses or concede control of airspace across the theater. Either option meant strategic defeat. The Betty bomber had become operationally obsolete not through technological advancement by the enemy, but through exposure of a fundamental design flaw that could not be fixed in the field. The aircraft built to dominate the Pacific was burning out of the sky, one fireball at a time. The mathematics were precise, the consequences were not. Major McCoy's technical team spent weeks dissecting the captured Betty at Clark Field. Every component was weighed, measured, documented. The analysis revealed exactly what Japanese engineers had traded for range, and why that trade had seemed logical in 1937. A complete self-sealing fuel tank system would have added approximately 800 kilograms to the Betty's empty weight. Armor plating for crew protection, another 300 kilograms. Fire suppression systems, armored fuel lines, protective bulkheads, 200 kilograms more. Total protective systems, roughly 1,300 kilograms. That weight represented 15% of the Betty's total payload capacity. It meant 400 fewer kilometers of range. It meant fewer bombs carried to target. It meant the difference between reaching distant Allied bases and falling short in empty ocean. The American analysis team traced the decision back to its origin, the 1937 Imperial Japanese Navy specification for a new land-based attack bomber. The requirements were contradictory by Western standards. Maximum range 3,700 kilometers, maximum speed 400 kilometers per hour. Bomb load 800 kilograms, crew 7 men, and the specified empty weight under 6,800 kilograms. No American or European aircraft met those specifications. No engineer following Western design philosophy could satisfy those requirements. The numbers demanded eliminating something fundamental. Chief designer Kiro Honjo faced an impossible equation. Build a bomber with crew protection and lose the range that made it strategically valuable. Or build a bomber that could reach any target in the Pacific but couldn't survive interception. There was no middle option. The physics allowed no compromise. Honjo chose range. The decision was methodical, calculated, deliberate. Every kilogram devoted to protection was a kilogram not available for fuel. Every armor plate meant reduced payload. Every safety system shortened the aircraft's operational radius. The engineering logic was sound. In 1937, Japan anticipated a short war against enemies with limited air defenses. The Betty would strike quickly, decisively, before opposition could organize. Range enabled surprise. Surprise enabled victory. Crew survival mattered less than mission success. The design philosophy reflected broader Japanese military doctrine. Accept casualties to achieve objectives. Aircraft were expendable if they accomplished their mission. Crews understood their role. The samurai tradition valued sacrifice over survival. American engineers examining the Betty at Clark Field understood the trade-off intellectually. What they couldn't comprehend was accepting it operationally. Western air forces treated trained crews as irreplaceable strategic assets. Losing experienced pilots meant years of training investment wasted. American doctrine prioritized bringing crews home, even at the cost of reduced performance. The Betty's design revealed a fundamental philosophical difference. Japan optimized for mission capability. America optimized for crew survivability. Both approaches made sense within their respective strategic contexts. Japan, facing resource limitations and assuming short conflicts, built aircraft that maximized immediate combat effectiveness. America, with vast training infrastructure and industrial capacity, built aircraft that preserved human capital for extended warfare. The question wasn't which philosophy was correct. The question was which philosophy would prevail when the war lasted years instead of months, when attrition replaced surprise, when trained crews became impossible to replace. By 1945, standing in the wreckage of Japan's air power, McCoy had his answer. The Betty's unprotected fuel tanks weren't a design failure. They were a perfectly executed solution to requirements that assumed a war Japan didn't fight. The engineering was flawless. The assumptions were fatal. The design philosophy demanded a price. Crews paid it. April 18, 1943, Admiral Isoroku Yamamoto, architect of Pearl Harbor and Japan's most irreplaceable strategic mind, departed Rabaul aboard a G4M Betty bomber. The aircraft's range made it the only option for his inspection tour of forward bases across the Solomon Islands. American codebreakers intercepted the flight plan. 18 P-30 Lightning fighters launched from Guadalcanal on a precision intercept mission, 560 miles over open ocean, flying at wave-top height to avoid detection. At 9:34 a.m., the Lightnings found Yamamoto's formation over Bougainville. The P-38s opened fire. Yamamoto's Betty erupted in flames within seconds, the unprotected fuel tanks igniting instantly. The aircraft crashed into the jungle. There were no survivors. Japan lost its most capable naval strategist because the only aircraft that could fly the mission couldn't survive interception. The Betty's range had made Yamamoto's inspection possible. Its vulnerability made his death inevitable. The pattern repeated across the theater, mission after mission. March 21, 1945, 18 Betty bombers launched from Kanoya Air Base carrying Oka kamikaze rockets, piloted missiles slung beneath the bombers' fuselages. Each Oka required the Betty to penetrate within 20 miles of American carriers before release. The bombers never got close. American fighters intercepted the formation 60 miles from the fleet. Every Betty was shot down before releasing its payload. The Okas, each carrying a pilot trained specifically for suicide missions, fell into the ocean still attached to their mother aircraft. 18 Betty crews killed, 18 Oka pilots killed, 0 American ships damaged. The mission failed not because of tactical error, but because Betty bombers couldn't survive long enough to deploy their weapons. The aircraft built to deliver decisive strikes had become a liability that ensured failure before engagement. At Guadalcanal, the losses became statistical inevitability. The campaign consumed Betty squadrons completely. August through November 1942, over 150 G4M bombers destroyed, not damaged, not forced to land. Destroyed, exploded in mid-air, disintegrated on impact, burned completely with no survivors recovered. Crews understood what they were flying. Ground personnel watched formation after formation depart, knowing half wouldn't return. Pilots wrote final letters before missions, not from pessimism, but from mathematical reality. Navigators calculated fuel loads, aware that every liter of range was purchased with vulnerability. The Betty's cockpit offered no protection. Pilots sat behind windscreens that couldn't stop rifle-caliber rounds. Bombardiers worked in nose sections that shattered under minimal fire. Tail gunners manned positions surrounded by unarmored fuel tanks. When tracers found fuel, the tail section became an inferno with no escape route. Japan's infrastructure couldn't replace losses. Experienced crews, men who'd sunk Prince of Wales, who'd struck Darwin, who'd mastered long-range navigation across featureless ocean, died faster than schools could train replacements. By late 1943, Betty squadrons flew with partially trained crews whose lack of experience increased vulnerability further. The aircraft didn't just kill crews, it consumed them. Every sortie was a calculated sacrifice. Every mission accepted losses as inevitable. The design that prioritized range over survival had created an aircraft that crews flew knowing they were expendable. Not valued assets to be protected, but ammunition to be expended. The samurai tradition valued sacrifice. The Betty demanded it. By the time Japan recognized the problem, the solution was impossible. Early attempts at field modifications began in late 1942. Ground crews at Rabaul installed rubber sheeting inside fuel tanks, makeshift self-sealing systems cobbled together from available materials. The modifications reduced fuel capacity by 15% and added weight that decreased range proportionally. The protection proved inadequate. Betty still exploded under fire, now with reduced operational radius. Engineers tried carbon dioxide fire suppression systems retrofitted to existing airframes. The equipment was heavy, complex, and required modifications that weakened structural integrity. Most critically, the systems couldn't extinguish fires fast enough. Fuel ignited faster than suppression could respond. The modifications saved almost no one. Armor plating for crew positions came next. Steel plates behind pilot seats, reinforced bulkheads protecting fuel lines, armored windscreens. Each addition reduced the aircraft's effective range and increased fuel consumption. The Betty lost the one advantage that had justified its vulnerability and gained protection insufficient to ensure survival. The fundamental problem was irreversible. The airframe was designed around unprotected fuel. Adding protection meant redesigning weight distribution, structural load paths, fuel system architecture. It meant building a different aircraft. Mitsubishi began work on the G4M2 variant with genuine self-sealing tanks and improved armor, a proper solution that required 2 years of development. The G4M2 entered service in mid-1944. The self-sealing fuel tanks worked. The armor protected crews. The fire suppression systems functioned as designed. But the modifications reduced range by nearly 30%. The aircraft that once struck targets 600 miles away now struggled to reach 400. Maximum speed dropped from 428 to 380 kilometers per hour. Bomb load decreased from 1,000 to 800 kilograms. The Betty had become a mediocre medium bomber, slower than American B-25s, shorter range than B-26s, carrying less payload than either. The advantage had disappeared completely. The G4M2 couldn't reach targets the original Betty had struck routinely. It couldn't outrun American fighters. It couldn't carry enough ordnance to justify the mission risk. Protection had been achieved by sacrificing everything that made the aircraft strategically valuable. Production continued anyway because no alternative existed. Japan's aircraft industry couldn't retool for completely new designs. Resources didn't allow development of replacement bombers. The Betty remained in production because stopping meant having no land-based attack capability at all. Squadrons flew protected Bettys on shorter-range missions against better-defended targets with diminished payloads. The losses continued, reduced but not eliminated. The aircraft still burned when hit, just less reliably. Crews still died, just occasionally survived. The original design philosophy, range at any cost, had been abandoned, but the aircraft couldn't escape its fundamental architecture. The G4M2 was a protected bomber built on an airframe designed to be unprotected. Every modification fought against the original engineering intent. By 1945, the Betty was operationally obsolete. Not because American technology had surpassed it, but because the design decisions made in 1937 couldn't be corrected within the existing airframe. The attempt to add protection had eliminated capability without achieving survivability. The aircraft that once symbolized Japanese air power's reach had become a symbol of strategic miscalculation, a weapon designed for the wrong war, discovered too late to matter. August 19, 1945, two white-painted Betty bombers lifted off from Kisarazu Air Base. The aircraft bore green crosses instead of red Hinamaras, neutral markings for a mission no one had imagined in 1941. Aboard were Japan's surrender delegation, diplomats, military officers, and foreign ministry officials traveling to meet MacArthur's staff in Manila to arrange the formal end of hostilities. The same aircraft type that had annihilated Clark Field on December 8, 1941, now carried Japanese representatives to that same base to negotiate terms of surrender. The Betty bombers that had sunk battleships and dominated the Pacific's opening year would deliver Japan's acknowledgement of defeat to the airfield where their war had begun. The symbolism was inescapable. The circular path, from Clark Field's destruction to Clark Field's surrender, encompassed the entire arc of Japan's Pacific War. The aircraft that symbolized unstoppable reach in 1941 now symbolized exhausted capability in 1945. The White Bettys flew unarmed, unescorted, vulnerable. But vulnerability no longer mattered. There were no enemy fighters to intercept them. The missions didn't require combat survival, only the ability to deliver passengers across distance. The unprotected fuel tanks that had doomed thousands of crews were irrelevant on flights where no one would shoot. In a final irony, the Betty was performing the mission it had always been designed for: long-range transport across vast oceanic distances. No bombs, no torpedoes, no combat. Just the pure expression of range that Kirohonjo had optimized in 1937. The surrender Bettys landed at Ieshima on August 19th, then continued to Manila on August 20th. Japanese officials emerged onto Clark Field's tarmac, the same concrete that had burned 4 years earlier under bombs delivered by the aircraft that now carried them. The circle was complete. The G4M Betty had opened the Pacific War with devastating effectiveness, its range enabling strikes that redefined naval and air combat. It had demonstrated that distance was no longer protection, that air power could project across oceans, that capital ships could be destroyed by aircraft alone. But the same design philosophy that made those victories possible had ensured the Betty's eventual obsolescence. The unprotected fuel tanks that enabled strategic reach became suicide traps when opposition materialized. The aircraft built to dominate a short war couldn't survive a long one. Thousands of Japanese airmen had died in Bettys that exploded from single hits. Yamamoto had died because the aircraft's range made his inspection tour possible but couldn't protect him during it. Entire squadrons had been consumed in flames over Guadalcanal, Rabaul, and across the Pacific, and now the last Bettys flew painted white, carrying surrender documents. Don't just watch, subscribe. Help Mr. WW2 Archives. Declassified hit 1,000 subscribers. The weapon that had once symbolized Japan's reach and power had become the messenger of its defeat. The aircraft that couldn't bring its crews home alive had brought Japan's war to its inevitable conclusion. Major Frank T. McCoy's discovery at Clark Field in January 1945 had explained why. The naked fuel tanks, the thin aluminum, the absent protection, the deliberate trade of survival for capability, had always contained the answer. The Betty bomber was never meant to survive. It was meant to reach far, strike hard, and win quickly. When the war lasted years instead of months, when attrition replaced surprise, when survivability became more valuable than range, the aircraft's fundamental design became its epitaph. The circle had closed. The weapon that began the war had escorted it to its end, carrying the final acknowledgement that capability without survivability was always temporary. The Betty's war, like Japan's, had burned itself out.